Lesson 37, Analyzing Data for Two Dependent Samples. Example 1. On average, does a person's dominant hand react quicker than their non-dominant hand? In order to address this question statistically, a random sample of 7 test subjects had the reaction time of both their dominant hand and non-dominant hand measured. The following results were observed. So this random sample of 7 test subjects each had their dominant hand reaction time measured and their non-dominant hand reaction time measured. This data involves 2 dependent samples since paired data values were recorded from the same sample subjects. Thus, the difference in the 2 dependent samples is calculated and analyzed using one population inferential statistics methods. So we calculate the difference in the reaction times for each of the test subjects by taking the dominant hand reaction time and subtracting the non-dominant hand reaction time, thus giving us the following differences. We can enter these differences into our TI-84 calculator. To do this, we would press Stat and then enter the data editor. I'm going to enter the differences into list 1. So I'm going to clear out the old data by using the arrows to navigate up to the list name and then press Clear Enter to clear out the old data. Now in list 1, I could enter in the differences by typing in the 452 and subtracting the 476. Enter. The second subject, difference was 410, subtract 415. Enter. 388, subtract 381. Enter. 463, subtract 516. Enter. 479, subtract 461. Enter. 392, subtract 404. Enter. Finally, 507, subtract 471. Enter. So thus, we have the differences in the reaction times between the dominant hand and non-dominant hand inputted into our list 1. Now we could use these differences to answer the following question. Assuming that people's reaction time reasonably follows a normal distribution, can one conclude from these sample results that, on average, a person's dominant hand reacts quicker than their non-dominant hand? Well, in this example, we're assuming that people's reaction time reasonably follows a normal distribution. Now, this is important because in order to apply inferential statistics methods, which rely on the results of the central limit theorem, when the sample size is not sufficiently large, the population from which the random sample was selected must reasonably follow a normal distribution. So in this case, we only took a random sample of 7 test subjects. This was not sufficiently large. So we need to reasonably assume that the people's reaction time follows a normal distribution in order to continue on with this particular data analysis. Now the question is, can one conclude from these sample results that, on average, a person's dominant hand reacts quicker than their non-dominant hand? Well, there are 2 possible answers to this question. Either yes, one can conclude, or no, one cannot conclude. In order to address this question statistically, we must conduct a hypothesis test procedure, because the resulting hypothesis test procedure will take the data and allow us to conclude either yes, this is a valid idea, or no, it's not a valid idea. Now, to state this hypothesis statistically, we see that we're referring to the reaction time on average. So it involves a mean between a person's dominant hand and non-dominant hand. Well, even though these are 2 different data values, these 2 different data values were collected from the same sample subjects, thus making this a 2 dependent sample. In this case, to do the hypothesis test, we involve the differences in the data values. The difference would be the first data value subtract the second data value. In this problem, the person's dominant hand is mentioned first in the question, and the person's non-dominant hand is mentioned second. Thus, we will take the dominant hand reaction time and subtract the non-dominant hand reaction time to get the difference in the reaction times. Now here, the problem's stated, on average, does a person's dominant hand react quicker than their non-dominant hand? Quicker reaction times are your less than reaction times. That is, 400 milliseconds is quicker than 500 milliseconds. Thus, when we take a lower data value minus a larger data value, we're left with a negative difference, or one that is less than 0. So the hypothesis we'd be testing here is the on average, the mu, difference between the dominant hand and non-dominant hand reaction time will be less than 0. This is the case when the answer is yes, the person's dominant hand does react quicker than their non-dominant hand on average. So we'll be conducting a hypothesis testing procedure for one population mean. So we look to the following steps to guide us through our hypothesis testing procedure, starting with stating the hypotheses statistically. Here, we indicated that we're looking at the mu, the mean difference is less than 0. This would indicate that the dominant hand does react quicker on average. But if the answer is the opposite, no, it does not react quicker, then we'd be looking at the idea of the mu, the mean difference, is greater than or equal to 0. Now, because the greater than or equal includes the condition of equality, we always label that condition as HO. The opposite, without the equality, is labeled as the H1. So here, we're testing a hypothesis of HO, that mu, the mean difference, is greater than or equal to 0, versus the H1, that mu, the mean difference, is less than 0. In this case, H1 would correspond to a yes answer. Yes, we can conclude that on average a person's dominant hand reacts quicker than their non-dominant hand. But if the data supports the HO, HO would lead to the no answer. No, there is not enough evidence to conclude that a person's dominant hand reacts quicker than their non-dominant hand on the average. Now that we've stated the hypothesis statistically, next we identify alpha, the level of significance. Here we're going to use the customary alpha equals 0.05. Next, t-test. T-test is the command on the TI-84 calculator that we'll use to calculate the p-value we need to reach our decision. So we can go to the TI-84 calculator, where we've already entered in the differences in list 1, and we could press stat, arrow over to tests, and then arrow down to t-test. Enter. Well, here we have as input the actual data. So we arrow the cursor over to data and press enter to select. Down arrow. Mu0 is the actual number that's contained in the hypothesis. In this case, the number is 0. Down arrow. List is the list we put the differences in, which was list 1. Freak was 1 because each data value came from one person. And the inequality in H1 is a less than. So I arrow over to the less than, press enter to select, and then down arrow to calculate, where we press enter. And amongst all the different results the t-test command gives us, the one that we need is the p-value, the one that says p equals. So here, rounding off the p-value to the nearest thousandth, we get a p-value of 0.341. So now that we have our p-value, we can make our decision. Since the p-value of 0.341 is not 0.05 or less, the decision is to not reject HO. So here we do not have enough evidence to reject HO. So we do not reject HO. And when we do not have evidence to reject HO, that also means we do not have evidence to conclude H1. Since H1 was the mu, the mean difference, is less than 0, that is, on average the dominant hand does react quicker, and since we do not have enough evidence to conclude that, we can now answer the original question in words of the problem. So, based on our results here of our hypothesis test procedure, we can state the following conclusion. Therefore, assuming that people's reaction time reasonably follows a normal distribution, one cannot conclude from these sample results that, on average, a person's dominant hand reacts quicker than their non-dominant hand. Now, you must be careful when trying to interpret this conclusion, because one reason why one cannot conclude from these sample results that, on average, a person's dominant hand reacts quicker than their non-dominant hand is because this is not true, and a person's dominant hand does not react quicker than their non-dominant hand on average. That's why one cannot conclude this based on this result. But another explanation for why one cannot conclude from these sample results that on average a person's dominant hand reacts quicker than their non-dominant hand is because even though this may be true, we just didn't have sufficient sample evidence to indicate so. So maybe if we had a larger sample, we might have eventually enough evidence to conclude this. But based on the evidence that we have, one cannot conclude from these sample results that on average a person's dominant hand reacts quicker than their non-dominant hand.